X64 registers evolved from 16-bit registers in the 8086 through 32-bit registers in IA32 architecture to 64-bit registers in modern machines. Current processors have 15 general-purpose registers for data storage, data manipulation, and indirect addressing. Some literature states that the stack pointer is also considered a general-purpose register. This brings the total number of general-purpose registers to 16. In the X64 architecture, registers have some special functionality assigned. RAX is the accumulator. It is used for general data manipulation, and some instructions work only with the accumulator. RBX, base register, name comes from indirect addressing in base addressing mode, but currently any register can be used for this purpose. RCX, counter register. It is used for iteration counting for loops and repeated instructions. RDX, data register, is used as an extension of the accumulator and also as a 16-bit size for I/O addressing space addressing. RSI, source index, is used for addressing source, data tables, or strings. RDI, destination index, is used for addressing destination data tables or strings. RBP, base pointer, often used for accessing the so-called stack frame, which is a place for arguments and local variables inside functions. RSP, stack pointer, it is used for stack manipulation, automatically handles storing and retrieving the return address of procedures while calling and returning. Registers can be accessed as 64-bit, 32-bit lower order half, 16-bit lower order quarter named word, and 8-bit lower order byte. The low order word of 4 registers RAX, RBX, RCX, and RDX can be accessed in 2 8-bit halves. The lower half has L letter and the upper half has the H letter in the register name instead of X. For example, lower word of an accumulator can be accessed as high order byte AH and low order byte AL. In 64-bit machines, additional registers R8 to R15 were added. Here naming is a little bit different. The 32-bit lower order half has a D suffix. The 16-bit lower order quarter has a W suffix, and the 8-bit lower order byte has a B suffix. All these registers can be used as any other general-purpose register to store data, perform calculations, or for indirect addressing. Every processor has a register containing bits used to inform the software about the state of the arithmetical logic unit, about the result of the last arithmetic or logic operation, and used to control the behavior of the CPU. In X64, it is called flags register. As the flags used in arithmetic and logic calculations and in conditional instructions are all present in the original 16-bit flags part, let's consider the low-order quarter of flags only. Let's describe the meaning of informational flags. CF, carry flag, it is set if an operation generates a carry or borrow. For example, if the result of an addition is larger than the destination operand. PF, parity flag, is set if the result of an operation contains an even number of bits equal to 1. AF, auxiliary carry flag, is similar to CF but informs about the carry or borrow from the 3rd to the 4th bit. It is used for BCD calculations. Zero flag is set if the result of an operation is 0. SF, sign flag, is a copy of the most significant bit of the result. OF, overflow flag, is set if the result of an operation is too large or too small to fit in the destination operand. It is used for signed arguments. Control flags allow modifications of the processor's behavior. TF, trap flag, is used for debugging to execute a program one instruction at a time. Interrupt flag, IF, if it is set, interrupts are enabled. DF, direction flag, it determines the direction of string operations. If cleared, string operations work from lower to higher addresses. If set, they operate in the opposite direction. The modern x64 processors have an extensive set of SIMD instructions. They use the set of vector registers called XMM, YMM, and ZMM. SSE instructions are executed with the use of 180-bit packed data. The SSE unit has 8 registers named XMM0 to XMM7. The YMM registers are the 256-bit extension to the XMM registers. They are introduced to implement the AVX set of instructions. Additionally, in 64-bit processors, the number of available YMM registers was increased to 16. ZMM registers are the further extensions of XMM registers to 512 bits. In 64-bit machines, 32 of such registers are available. Together with AVX extension and ZMM registers, 8 16-bit op-mask registers were introduced to x64 processors. They are named K0 to K7 and can be used, for example, to provide conditional execution on or mask several elements of vectors in AVX instructions. The SIMD instructions operate on integers, single precision and double precision floating point numbers. If you need a more precise calculation, you can use double extended precision with the floating point unit. Floating point unit has its own set of 80-bit registers named ST0 up to ST7, and they are organized as a stack. It is worth remembering that legacy SIMD integer instructions are MMX. They operate on 64-bit integer vectors and use MMX registers, which are physically mapped onto FPU registers. The x64 processors have 6 segment registers. As segmentation doesn't function in 64-bit long mode, we will not talk about these registers further, but if you need more information, please refer to our coursebook or the widely available documentation on the internet. In the x64 architecture, there are additional registers used for a variety of purposes. For example, the CR registers are used for controlling the operating mode of the processor, virtual and protected memory mechanisms, and paging. The debug registers control the debugging of the processor's operations and software. There are also memory type range registers, model-specific registers, machine check registers, and others. They are used to control the behavior of specific units of the processor, report on the processor's performance, and detect and report hardware errors. Mostly, these registers are not accessible to an application program and are controlled by the operating system. For more details, please refer to documentation of the processor.